All right, guys, so now we're going to see how limiting regions fit into acids and bases and how it all connects. Okay, so here we've gotten a reaction. Hydrochloric acid, sodium hydroxide forms salt and water. Now, in this question, they specified that there's 3 moles of hydrochloric acid, which will react with 2 moles of sodium hydroxide. And they ask, what is the limiting region? I've also drawn out a picture because I wanted to try and visualize it first, and I want to show you guys how it works. If you had a picture, and in an ideal world, if you were always able to draw out the number of moles instead of calculating, this is how you do it. You've got 3 moles of hydrochloric acid and 2 moles of sodium hydroxide. Remember, you've got your moles from your recipe, your mole ratio. In this case, it's 1:1, which will make 1 sodium chloride, 1 water. What this means is that every 1 mole of hydrochloric acid will react with 1 mole of sodium hydroxide. So those numbers in front are basically telling you the ratio. They're not telling you that you have 1 mole of hydrochloric acid and that you have 1 mole of sodium hydroxide. That is just a ratio. What you actually have is what is in the question. You've got 3 moles of hydrochloric acid, 2 moles of sodium hydroxide. Now what happens? So let me show you in the form of a picture first. According to the ratio of hydrochloric acid to sodium hydroxide, the ratio is 1:1, which means for every 1 mole of hydrochloric acid, it will react with 1 mole of sodium hydroxide to form 1 mole of sodium chloride and 1 mole of H2O. Again, 1 mole of hydrochloric acid, 1 mole of sodium hydroxide, which will form 1 mole of sodium chloride and 1 mole of water. Then we want to continue the reaction. We want to see what will happen with that hydrochloric acid. But remember, every 1 mole of hydrochloric acid needs 1 mole of sodium hydroxide. But the issue here is, where's the sodium hydroxide? It's finished. It's completely finished. What does that mean? The reaction can't continue. It has limited the reaction. The sodium hydroxide, the fact that it's not there, has now limited the reaction. It is the limiting reagent. Okay, that is how you'd figure it out if you had a picture. But unfortunately, it's grade 12. You need to work it out. You need to show how you did it. So the steps that I take. Step 1. is you actually need to write down what is the number of actual moles. And the reason why I want you guys to specifically do this step is because it can get really confusing. Some people can, confuse the mole ratio with the actual number of moles. The actual number of moles are given in the question. They are not here. This is not the actual number of moles. This is your recipe. It's telling you 1 spoon of HCl, 1 spoon of sodium hydroxide. Okay. What you actually get, where you actually get the number of moles, is in the question. But once again, guys, it's grade 12. They will not directly tell you you have 3 moles of HCl. They'll give you the mass. If they say the mass is 8 grams, you've got 8 grams of sodium hydroxide, you need to be able to convert your 8 grams into moles by identifying the formula that you can use. And if you guys remember the formula, N is equal to M over M. If you have 8 and you know that this is going to be 40 for sodium hydroxide, you can find the number of moles. Okay, so it's not going to be that simple. It's grade 12. Okay, so now, what is the number of actual moles? For sodium hydroxide, if you look at the question, they tell you you've got 2 moles of sodium hydroxide and you've got 3 moles of HCl. That is the first step. Identify how many moles you have. The next step is the ideal ratio or the ideal moles. Okay, so what I mean by this when I talk about ideal ratio and ideal moles is you need to construct a sentence. If you're still not comfortable with limiting regions, guys, construct a sentence like this. Start it off with for 3 moles of HCl, okay? Meaning you need to create a scenario where pretend as if you do not have any moles of sodium hydroxide. So if you look at this picture that I drew here, where we basically knew that we're starting off with 3 moles of HCl. So we know we started off with 3 moles of HCl and that we're also going to have 2 moles of sodium hydroxide. Now, I want you guys to imagine as if in a scenario that you're creating. Start with HCl or sodium hydroxide. But what you need to do is pretend as if you don't have any sodium hydroxide and you have 3 moles of it. And you're trying to figure out, if I've got 3 moles of hydrochloric acid, how many moles of sodium hydroxide do I need? That's basically step number 2. It's you saying, I know how much I have, okay? But let me just remove one of them. It's almost as if you're doing a recipe. You're trying to find out, look, I've got water and I want my juice to taste a specific way. How much Oros should I put in it? How much sugar should I put in it? Right, that's what you're doing here. So create an ideal recipe. As in, you know that you've got HCl, 1, 2, 3 moles of HCl. Now, let's remove our sodium hydroxide and try to find out how many moles of HCl, how many moles of sodium hydroxide will react with 3 moles of HCl. So you construct a sentence. That is the point of step number 2. Okay, but you have to create a mole ratio. You say the ratio of HCl to sodium hydroxide is 1:1. Where do we get that? From this reaction here. 1:1. So we say the ratio is 1:1. Okay. And if the ratio is 1:1, we're saying we have 3 moles of hydrochloric acid. How many moles of sodium hydroxide would need to react with that? Remember, we're removing the sodium hydroxide. We're pretending as if it doesn't exist. We're trying to create an experiment. We're trying to create a recipe. We want everything to be balanced out. Okay. So when you create this, what you end up noticing is that the number of moles of sodium hydroxide that you should have is 3 moles. Because if the ratio was 1:1, it means that if you've got 3 moles of hydrochloric acid, you would ideally need to have 3 moles of sodium hydroxide. That is ideal. That is the ideal recipe. Because in this type of situation, with a ratio of 1:1, 1 hydrochloric acid reacts with 1 sodium hydroxide, forms water and salt. And again, 1 hydrochloric acid reacts with 1 sodium hydroxide, forms water and salt. At some point, what you'll notice in this ideal recipe with 3 moles of hydrochloric acid and 3 moles of sodium hydroxide is that all of it is going to get used up. Everything is going to be completely neutralized. That is a complete neutralization, right? It's when nothing is left over. There's no limiting regions. There's no excess. Everything is finished. So that is an ideal situation. But also create one for your sodium hydroxide. Okay, if you're still not comfortable, once again, you can also do it with the sodium hydroxide. You can say, okay, I know that I've got 2 moles of sodium hydroxide. Okay, but what I want to do in this situation, I also know the number of moles of hydrochloric acid, but let me pretend as if I don't know it. Okay, let me just be like, hey, I don't know hydrochloric acid, take it out. And now you're going to ask yourself, okay, but if I've got 2 moles of sodium hydroxide, how many moles of hydrochloric acid would I need? Forget that 3 moles, right? Because remember, we're creating an ideal recipe, an ideal situation. So we say the ratio of sodium hydroxide to hydrochloric acid is 1:1. Meaning if you've got 2 moles of sodium hydroxide, how many moles of hydrochloric acid would you need? You do a cross multiplication, you see that you actually need 2 moles of hydrochloric acid. Okay, so now this answers a lot. Next step, compare. Okay, I know obviously guys, you're not always going to draw this table and do it like this, but I want you to take step by step. So when you feel that you're not comfortable with limiting regions, you do it like this, step by step. Eventually, you'll be able to formulate one beautiful equation and calculate it and do it without having to draw tables and everything. Okay, so now let's compare. So the ideal number of moles of hydrochloric acid, remember we calculated that now. We calculated that if we are focusing on sodium hydroxide, the ideal number of moles for hydrochloric acid is 2. We'd ideally like 2 moles of hydrochloric acid. But how many moles of hydrochloric acid do we actually have? 3 moles. Now let's look at sodium hydroxide. We also calculated that. We said If we want our sodium hydroxide to react with our hydrochloric acid, we would ideally like 3 moles of sodium hydroxide. But how many moles do we have? We've got 2. So now you're comparing. Because why? That helps you to find the limiting reagent. Because check this out. You would ideally like 2 moles of HCl, but you've got 3. You've got more moles of HCl than you need. You would ideally like to have 3 moles of sodium hydroxide, but you've got 2. You want 3 moles, but you only have 2. What's your limiting reagent? Which one is not enough, essentially? It is your sodium hydroxide. And that is what a limiting reagent is. That is how you find it. Limiting reagent, we want a complete neutralization. We want 3 moles and 3 moles, 2 moles and 2 moles. But in a situation that is not ideal, such as this one, our sodium hydroxide is not enough. We would like 3 moles of sodium hydroxide to react with the 3 moles of hydrochloric acid, but we don't have enough. So our limiting reagent, that sodium hydroxide, is going to limit our reaction from continuing, as I had shown you guys in the picture.